Now we introduce parameters to the functions that we define. Continuing with our earlier birthday example, you probably heard happy birthday sung to a couple of different people, and then when a new person, like Maria, was suggested to sing happy birthday to, you could figure out what to do, how to change the song and put in Maria's name. You wouldn't need the whole song given to you ahead of time, word for word. This is the power of abstraction. With a couple of examples, like for Emily and Andre, you can figure out how to sing to Maria. But C# is not that smart. We need explicit rules. If you were to give an explicit rule to people, you might say something like this. First, you have to be given a person's name, and then you instruct where to insert the person's name in the song. C# works something like that, but it has its own syntax. First of all, person's name serves as a stand-in for the actual data to be used. For instance, Emily, Maria. This is just like the association of a variable name in C#, but person's name is not a legal C# identifier, so we'll just use person for this stand-in for the actual person. It will be a variable in the program, so we need a type. And of course, names are strings, so the type of person is string. Now look at how we change our definition for the function. We still have static void happy birthday and open and close parentheses, but now in between the parentheses, in this definition heading, we have our type and name of this stand-in that we're going to use to explain how to sing happy birthday to any person. And then we use person, this stand-in, in the place where we insert the name in the definition here in the third line. Now, this is the definition of the function with its heading here. Technical name here is that person is a formal parameter. Now, distinguish when we actually choose to use the definition in our main program now. Again, we want to actually call and use the function. But now we again have something between the parentheses. Emily here corresponds to the person up here. And when we do this function call, Emily is called the actual parameter, which is then passed, that's the jargon, to the function definition, where it essentially becomes assigned to the variable person for substitution later when running the program. We can then call the function again. This time we can vary the actual parameter. Now a new string, Andre, is associated with the original formal parameter person, and we substitute a different name. Let's run this thing briefly. I've got MonoDevelop up. Here is birthday 4 project that we have it in. Let's run it. First, it printed happy birthday. Dear Emily, that was our first actual parameter. Then we passed Andre the second time, and Andre is then the value of the formal parameter when it's called again. Again, it's very important to understand the execution sequence here. And again, we've got more going on with the parameters now. Execution starts in main. The compiler has remembered this definition. When execution starts in the static function main, we call the happy birthday function with its parameter Emily. Execution moves to the code in the definition here. Now the actual parameter is passed, so it becomes the value of the formal parameter here. And as we run the lines of the function definition here, we substitute the value Emily for person. When we get to the end of the definition, remember we return to the place it was called from here, and then we go on to the next statement, call it again with Andre, and Andre is passed as the value of person, and it gets substituted. We finish the function call. We come back to the main program, but there's nothing left, so we're done. The text here follows this through, referring to the various lines. It was an important idea here that the two ways we sang happy birthday were very close, and we abstracted out the idea of the person we sing to, wrote the code so it works for any person, and we can sing to either Emily or Andre. This ability to make an abstraction combining the different ways of singing happy birthday, in this case, very silly, simple idea, is really important in programming, and we'll come back to it over and over. Another thing is an easy confusion is between the heading in the definition of the function and the call to the function. Just as we said before that we only have these modifiers static void here in the definition, we also now have a change in the parameter that we've added. We have the actual value of the parameter in the call to the function, and we have the type and name of the formal parameter to be used in the definition. It's easy to forget and look at the heading and include the type again down here, but that is wrong. The only place we put the type is the one place that we declare it here in the heading of the function. Here I have used several actual parameters, but they were canned data. There's a slight variation. Here we have the same definition of happy birthday in our birthday who program. Here we take our data from someplace else. We take our data from the user, prompting the user for a name that we call username, and we can use any expression that has a string value for the parameter. In particular, it can be the name of a variable that we've read in from the user. Quick run. So let's sing to George. And there we are. We read in the variable for George, passed it to the parameter, and now we're singing to George. There's a couple of useful ideas here in this latest version. There's multiple ways to get information into a function. The main way is to have a value passed through a parameter, as we have here. But here, of course, in the main program, we get in data from the user with a prompt and then obtaining data from the command line. User interactions are good to separate from processing data inside the program, and the use of this function facilitates that. We get a value from the user here in the main program, and then our happy birthday function doesn't depend on where we got the data. We pass it, whatever the data is, through the parameter the function then works.